Hello everyone, I'm Kavita, Assistant Professor from BCA Department, IIMT College of Management. Today I'm going to discuss a very important feature of object-oriented programming, that is polymorphism. In this tutorial, I'm going to discuss what is polymorphism, types of polymorphism, compile time polymorphism, function overloading, operator overloading, runtime polymorphism, function overriding, and virtual function. Let's start with the tutorial. The very first topic is what is polymorphism. The word polymorphism is derived from two Greek words. One is poly, another one is morph, where poly means many and morph means forms. When a member function or an object behaves in different manner under different circumstances, then it can be defined as polymorphism. If we took a real-time example of a teacher as an entity, a teacher can be an employee, can be a mother or a father, can be a sister or brother, or a citizen. That means a single entity teacher can exhibit different behaviors at different times. Now, next topic is types of polymorphism. We have two types of polymorphism. Number one is compile time polymorphism, and number two is runtime polymorphism. Till now, we know that polymorphism is a combination of two words, and it is a single thing that exhibits different behavior at a different time. If it is defined at compile time, that which behavior is exhibited by that single entity at runtime, then it is known as compile time polymorphism. And if the behavior exhibited by that single entity is defined at runtime, that means it is runtime polymorphism. Furthermore, compile time polymorphism is implemented by method overloading and operator overloading, and runtime polymorphism is implemented by virtual function and function overriding. Moving on to the next topic, that is compile time polymorphism. We have, first of all, the definition of compile time polymorphism. Here, polymorphism means that my single entity exhibits different behavior, but at a single time it exhibits a single behavior only. If it is defined that which behavior is going to execute at a given time, then at a given time, at compile time, this is known as compile time polymorphism. And this type of polymorphism is also known as early binding. Now, question arises, what binding means? Binding means the relationship between the function call and function definition, which means at a given time, the function call executes which body defined within the class, because we are having different bodies for single function calls. If the body is defined, which body is going to execute is defined at compile time. This is known as compile time polymorphism. Further on, compile time polymorphism is implemented by function overloading and operator overloading. Next, we are going to discuss what function overloading is. A function name having several definitions that are differentiable by the number or types of their argument is known as overloaded function, and this process is known as function overloading. For example, I am having add function with same name, but these all functions here are having different types of arguments. For example, here I'm having data 1 and data 2 is of n type. And here I'm having data 1 and data 2 is of float type. Similarly, in function overloading, I'm having same name function with different argument, type of argument, and also the number of arguments. For examples, here I'm having two data of integer type, and here I'm having number of data as 3, and 3 of them are of integer data type. Calling of overloaded functions, that means when in main I wrote area, I call function area as 12.5, sorry, 20.5, it will search for argument as a float and will execute this function, which is having float as an argument list. Similarly, if I wrote area 20.5, 10.5, that means a function area is going to execute with having two arguments as float. That is, which means this second function will be called. Similarly, if I wrote 20.5, 7, this third function will be called because I'm having float value 20.5 and other is int value, that is 7. Clear? Next steps involve in finding the best match. That means when I'm going to call any function in the main, what it will done here. First of all, the function call is going for the exact match. For example, if I will write area with 0 argument. Now here 0 is of integer type. That means first of all it will check for the function having data type as int. Now if we got the found, it will execute that type of function only. Next question arises, what will happen if we are not having the same exact match of data type, of argument type in the functions body? For that, we have promotional match. What promotional match means, if no exact match is found, then attempt is made to achieve a match through promotional of actual argument. For example, I wrote area with argument as C. Here C is of character type. Now in my class, I'm having only two areas function having argument as int and float. Now you can see no function is defined here with having argument as char type. Now what will happen to this? This C will be promoted to int type because the int type is the next promotional type to char. And what function is executed? This area int function will be executed, and according to that function's body, it will return the answer to you. Now, next one is the need of the function overloading. Function overloading not only implements polymorphism, but also reduces the number of comparisons in a program, and then thereby makes the programs run faster. Further on, I'm providing you a code that describes function overloading. Here, I'm taking 3 functions having same name, but with different arguments. Here I'm taking some name function with two arguments of integer data type. What this function will do? This function returns the summation of number 1 and number 2. Next, I'm having another function with same name but with different data types of arguments. And this function, what this function will do, this will return a double value, summation of two double values. Similarly, another function, now here I am having three argument types, and then I'm returning the summation of these three numbers. Now come to the compilation mode. When I'm compiling this code, we are starting with the main function. Here in the main function, first of all, cout will execute, the console output will execute. What it will do, it will print sum1 to your console, that is your monitor or whatever, what console you're attaching to your code. And next, this statement, what this statement will do, this will call some function with argument 5 and 6, which is of integer type. Now, first of all, it will going to match the data type of the argument, and according to that, this function will going to execute. That is, num1 will going to be 5 and num2 will going to be 6, and then it will combine 5 and 6 and return the value of 5 plus 6, that is 11, to you and print 11 here. Similarly, it will take 5.56.6 as an argument, goes to the second definition of function, and then return the double value. And on the same note, it will run and take 5, 6, 7 as an argument and will run the third definition of function and will print value as 18. Now, just took an example that if only two function definition is given to us, that is with double value as an argument list, and one is of 3 argument of data type int. Now, in main, if I wrote like this, sum with the argument 5 and 6 of integer type, it will first go for the best match. That means this function call will going to found a function having name sum with 2 argument of int type. Now, here in the function definition, I'm only having 2 functions, sum with double data type and with 3 arguments of int. Now, no exact match is here. What will going to happen? It will, if no exact match is done, what will happen next? It will promote this data type to its next data type that is provided in the function body. That means if I wrote 5 and 6, no matches, no exact matches found, then it will promote this 5 and 6 to double value. And this function call is going to be executed by this function definition. That is, F5 is going in num1 and 6 is to be going in num2. And it will return a double value to me, that is 11.0. Okay. Next is the restrictions on overloaded function. Any two function in a set of overloaded function must have different arguments list. Either of the number of argument, different number of arguments, or on the basis of different data type, right? Next is overloading based on different return type is erroneous. That means if I'm writing 2 functions and both are having same name with same number of arguments with same data type, of argument and having different return type, then this is not mentioned as function overload. Next point is function cannot be overloaded on the basis of one being static or another is non-static. Means static and non-static function is not the basis of function overloading. And last one is enumerated types are considered. Now, another implementation of compile time polymorphism is operator loading. In C++, we can overload an operator as long as we are operating on user-defined data types like objects or structures. Operator overloading means I am giving another function to a single operator. For example, here my plus operator, which is a binary operator, can behave differently in the both scenarios. If I'm taking data type, my operands as an integer type, it will return int value, that is 9. And if I talk string values as an operand, this same operator plus will return Rahul Kumar. That means what it is doing, it is just concatenating two strings. Means here my plus operators, different operator is same, but it behaves differently with different operands, with different types of operands. This is what operator overloading is. Now there are some restrictions with operator overloading. What is that? Operators can overload these operator overloading can be done by these all operators, but there are some operators that cannot be overloaded. One is your member access operator, that is dot operator. Another one is pointer to member operator. The third one is your scope resolution operator. Fourth one is your ternary operator. And last one is your size of operator. That means these 5 operators never be overloaded by operator. This is the restriction on operator. Now there are types of operator that can be overloaded. We already discussed that we can't overload this operator. What is this? This is ternary operator. I am having 3 types of operator in C++, unary, binary, and ternary, from which ternary operator can't be overloaded. Okay. So what are the remaining operators? Remaining operators are unary operator and binary operator. We can only overload unary operator and binary operator. There are 2 ways of overloading unary operator. One is using class function, another one is using friend function. Similarly, for overloading binary operators, I'm having class function and friend function. Okay. And the third ternary operator can't be overloaded. I already told you that operator overloading is a generalized way of function overloading. That means in the background, what we are doing, we are making an operator function. Means we are providing a function and function name as operator. Similarly, what we had done in function overloading. Now the question arises, how is it possible that a function name is a symbol? Yes, the C++ compiler provides you the provision of giving a function name as symbol with the help of this keyword that is known as operator. Now let's see how it is doing operator overloading using operator function. Here I am making a function, operator function, and this is my operator symbol that I want to overload with the help of this keyword that is operator. This is similarly as a function overloading syntax. What I'm having here is I'm having what here? Here is my symbol that I want to over. And this whole is a syntax of overload. For example, if I want to overload a unary operator which is provided in a class complex, then how we will write it? We will write here the class name as a complex, then defined with this scope resolution operator. This is my operator keyword, which makes this plus symbol as a function name. And this is my operator function. And here it is, this is my return type, which is the type of data which I want to return. Similarly, to operate a binary operator, what I'm having this as my class name. This is the operator I want to overload with the keyword operator. And here C1 as a parameter on which I'm going to operate, means the data on which I'm going to operate this. I'm on this plus operator, and then last the return type as complex. I already told you that operator function can be done with a simple class function and also with the friend function. When I define it as a friend function, I provide a keyword friend here, and the rest of the syntax is same, but a difference is there when when I provide friend function to overload unary operator. I pass a single argument for unary, and I will pass two arguments for binary operator. In class function, I just I did it. What I did, I provide zero argument with unary and one argument with binary. Okay. Now here is one of the code or one of the example of operator overloading. What I did here, I use to overload plus function. In this whole example, I am just adding two complex number. Now two complex number, here I represent two complex number with an object, and object can't be simply added with plus operator. That means what I did here, I just overload this plus symbol to operate on objects. Now come to the code. Let's see what is in the, within the code. I'm taking this complex as a class with two properties as real and imaginary. Here I'm having complex constructor, default constructor, and assigning 0.0 to both. One is real, another is imaginary. Next, I'm having a parameterized constructor to provide values to this real and image. Third, I am having this function as my operator function, because here function name is plus symbol, means this is my function name, and this function name plus is allowed only when I provide this keyword as operator. This whole is my operator overloading operator function. Okay, now just check out the execution of this program. The execution will start from the main. Okay. Execution starts with the main. When I'm having a complex number, When I'm having a complex as a class, I just provide here with two objects as A and B. What is first going? When I provide an object, memory space will be given to A with two properties, that is real and imaginary. And next, what I'm doing, I'm providing another object B with real 11.0 and 2.2. And the third, I provide another object that is C. When these two objects initiates, it will call parameterized constructor, this one. And what this object will do, it will provide 11.2 for real value of A and 12.3 for imaginary value of A. Similarly, for B object, it will provide 11.0 for real and 2.2 for imaginary. And for C, it will call this default operator, constructor, and provide real as 0.0 and imaginary point as 0.0 also. Now, after the execution of this first line, I'm having two objects, A and B, A with value 11.2 and real with 12.3, B with 11.0 and real with 2.2, and C with 0.0 and 0.0. Okay. Next, what will it do? It will print a string on the console that enter real and complex coefficient of the first complex number, and you provide A dot real and A dot imaginary. No need to provide this because I already provided with the parameters. Just skip these four lines. Okay. Now come to the last line. I provide here addition of additional result, and what I do here, sorry, I just add two objects A plus B. When I just add two objects, what at the background will happen? This object will call my plus operator function and pass parameter as object as B. Pass object as argument as B. That means this line, this particular line A plus B will goes to this section and provide here as B. Now my B goes to OBJ because I am passing it this B. This is my object. I'm passing this object here, and what is the data type of an object? Every time it's a class name. That's why I wrote here is a complex. What it will do? Just check out, please. Here in the body of the function, in this body of the operator function, I provide a temporary object. Why I call it as an object? Because here the data type is complex. That means this is a object. In this temp object, what I am doing, I am taking imaginary value and providing imaginary value of temp as a summation of A dot image and B dot image. So for that, I wrote the line as this dot image plus obj dot image. What obj here? Obj here is B. That means my second object. So that means what it will goes here. Here it will go. It will print 11.0. When I wrote obj dot image, it will provide 2.2 here. And when I wrote this dot image, what this pointer will do? This pointer basically prints the value of the calling function. Which one is the calling function? Calling function is A. That means here A dot image is going to print. A dot image is my 11.2 and B dot image is 11.0. That means 11.2 and 11.0 will submit here, and this will goes to temp dot image. Okay. Similarly, 12.3 will go to this dot real because the calling function is A, and 2.2 is going to obj dot real, and the summation will provide it to temp.real. Test, I return temp, and then this temp is goes to C. Now when I wrote C dot display, the summation of both complex number will print, and the output will be 22.2 and 45. Clear? Next, here is example of overloading function, operator overloading, a simple unary operator overloading with simple member function and with friend function. Come to the friend function, please. Here, what I am doing, I am making a class with the properties d1 and d2 and providing a parameterized constructor with d1 and d2 for assigning the data1 and data2, also having a display function and mentioning here a friend function, which is an operator function with an operator as a argument as my object. Here I am overloading unary operator. That means how many arguments I am having here? Only one. If I am operating binary operator, how many arguments are there? There will be two. Okay, then this is the body of the function. Simple. I'm just providing and making the data as means negating the data by providing a minus symbol here. I'm calling this function and this object as minus my m by c. What it will do, it will provide 24 here and 38 here with negate values, means negative values. And the result will be, it will negate the value of m by c. Okay. Now next is the need of operator overloading. It makes the code readable, extension of languages to improve user-defined data types, makes operator sensitive to construct, and the last important one is generalization of function. The rules of operator overloading, only the existing operator can be overloaded. That means we can't create any additional object to overload. Only the operator that are provided to the compiler can be overloaded. Next one is the overloaded operator must contain at least one operand of user-defined data type. That means overloading means that we are providing a special feature to the operator that is not provided with a compiler. For that, we have one user-defined data type should be masked in the operation what we are doing. Next, when binary operators are overloaded through a member function, these two types I already discussed, that unary for unary. See, with simple class function, I am having no argument. With friend function, I am providing one argument. Similarly, with binary operators, there is two arguments with the friend function and single argument with class function. Okay. Now next, come to the next topic, next type of polymorphism, that is runtime polymorphism. Runtime polymorphism is also known as late binding and dynamic binding, because here the binding between the function call and function definition is defined at a runtime. And this type of polymorphism can be executed with the help or can be implemented with the help of virtual function and function overriding. Now come to the topic function overriding. What function overriding is? Function overriding basically implemented with inheritance only, because function overriding defines that we are having two functions with same name and same argument, and within one class this is not possible, that we are having same name with same number of argument and same type of argument. So for providing function overriding, inheritance must be there. By inheritance only, we can have two functions with same name and same arguments. One is from the base class and another is from the derived class. Let's discuss more what function overriding is? Function overriding is an application of runtime polymorphism where two or more functions with the same name and same argument and accompany different classes of the same structure. Okay. This I already discussed with you that function overriding takes place when you derive class and the base class both contain the functions having the same name. Because only on that case, in that case, we have a class with same name of function and with same number of arguments. Now let us take an example. If I'm having a class hierarchy as animal, where animal is further divided into reptile and mammal, and reptile is further, the reptile class is further divided into snake and lizard, and here mammal class is further divided into dog, cat, cow. Now, if I'm taking this hierarchy, my reptile class has a property to crawl, means a reptile can crawl. That means a snake can also crawl because inheritance means the properties of reptile come to the properties of snake also. If a reptile can crawl, the snake can also crawl. This is the property of inheritance. Now, this took an example of function overriding. Here, I made a class of a reptile and provide a function as a crawl. Then I inherit a class snake. Means I make a derived class of this reptile class. This is my child class and this is my parent class. Now the properties of parent class come to the child class also. If I provide a function here also a crawl. Now my reptile, because snake can crawl and reptile can also crawl. This means the property of crawl is provided to both of the classes. Okay. Now, if in main function I make a object as of snake as derived one and wrote derived one dot crawl, what will happen? My snake function, snake class is having two crawl functions. One is itself his crawl function itself. Another crawl is come from the reptile class. That means my snake class is having two crawl functions. Okay, one is from the base class and one is of his itself. Then what will happen if I wrote derived one dot crawl? This crawl function, when I want to display, when I want to run the crawl function, what will happen? My snake's crawl can override my reptile's crawl. This is known as function overriding. That means what my output will be? My output will be snake can crawl. Because what which object I made here is derived one. Derived one is of which type? Snake. That means this derived one can call his function. Okay, this call and not the reptile's function. This is known as function overriding. Here the parent's crawl function is overridden by the child crawl because the object is of child. So this is all about function overriding. Another implementation of runtime polymorphism is virtual function. Virtual function, what virtual functions are? Virtual function are the member function of the base class which are overridden in the derived class. When you make a call to such functions by using a pointer reference to the base class, the virtual function is called and the derived class version of the function gets. Let's see this definition with the help of a code. I'm taking the similar code which I took earlier with the function overriding example. Here what I am doing, I am making a pointer reference. I already told you the definition of virtual function, that when you make a call to a function by using pointer or reference. With a simple function call, it can behave as I told you earlier, that means it overrides the base class function. But if we take a pointer or a reference to the base class, the working is different. How? You see, here in the main function, what I did, I make a pointer of reptile class. This PTR is of which type? Type is of reptile type. Okay. Now, if I pass the address of R to PTR, that means now my PTR is pointing to object R. R means reptile. If I call r.crawl, what it will print? It will print reptile can crawl, this one. Okay. Similarly, if I put an address of S to the pointer, now my pointer is pointing to what? My pointer is pointing to S. S is object of which class? S is an object of snake class. What I want to print here? I want to print here snake can crawl. Okay, but if I I want here to print snake can crawl, but what will print here? It will print reptile can crawl. Why? Why is it so? Because here the pointer is of reptile class. That means in both the cases, the pointer is of reptile class, and if you check the data type for the pointer, which is of reptile. And then when we call PTR, crawl with the help of PTR. Sorry, what I wrote here. There should be PTR. PTR, then calling remember pointer, then crawl. Rectify this. Please rectify here. Here there should be what should be written here. Here should the word is PTR. There is some error in the code. So when I wrote here PTR pointer to axis symbol, and then call with the help of pointer symbol, when I want to print crawl, what it will print? It will print reptile can crawl in both the cases. But now I want to print snake can crawl. For that, I made this crawl function as a virtual function. When I provide virtual keyword here, it will check not the data type of PTR. What it will check? It will check whether this function is virtual or not. If this function is virtual, it will not print the reptile crawl, and what it will print? It will print snake can crawl, like this. This here in the code, I wrote virtual here, the crawl function as virtual. That means when I took a pointer PTR, and with PTR dot crawl, I will call this crawl function. This function will print reptile because our address goes to PTR, and when I wrote PTR dot crawl, it will print snake can crawl, because now address of S goes to PTR. This is all about the virtual function. With this slide, with this topic, I'm going to end of this tutorial. Thank you very much.